from AC department and my teammate JONE, ANGELIN, FRENI, she also from AC department. My project is about home cleaning automatic robot, a robotic vacuum cleaner, sometimes called as RoboVac. A generic trademark is an autonomous robotic vacuum cleaner which has a limited vacuum cleaning system combined with sensors and robotic with programmable controllers and cleaning routines. In a present day scenario, we are all so busy with our work that we don't have the time for cleaning our house properly. The solution to the problem is very simple. You just need to buy a domestic vacuum cleaner robot such as Robo, which can clean your house with the press button. But such commercial products share one common issue, which is cost. So today we decided to make a simple floor cleaning robot which is not only simple to make but cost very less compared to the commercial products available in the market. Frequent readers might remember our Ordina vacuum cleaning robot, which we built a long time ago, but that one was very bulky and needed a big lead acid battery to move around. The new Ordino vacuum cleaner we are going to build here, which will compact and more practical. Materials required to build Ordino based floor cleaning robot: DC motor, battery, Arduino, ultrasonic sensor, micro servo, buzzer, hobby gear motor, H-bridge motor drive, LED resistor, slide switch. As we have used very generic components to build the hardware section of the vacuum cleaner robot, you should be able to find of those in your local hobby store. Here is the complete list of the required material along with the image of all the components. In the future section, we have talked about a future where the robot can decide a staircase and can prevent itself from falling. To do that, IR sensor, we will make an difference between IR sensor and Arduino. The working of the IR proximity sensor is very simple. It has an IR LED and often photodiode. The IR LED emits IR light, and if the obstacle comes in front of the emitter light, it will be reflected, and the reflected light will be detected by the photodiode. But the generator voltage from the reflection will be very low. To increase that, we can use an amp comparator. We can amplify and get output. An IR module has 3 pins: VC, ground, and output. Usually the output goes low when an obstacle comes in front of the sensor, so we can use to detect the floor. If the split second we detect a high from the sensor, we can stop the robot, turn it back. Arduino based floor cleaning robot. The complete code for this project is given at the end of the document. The Arduino code is similar to the Arduino based ultrasonic sensor code. The code can change the flow direction. The following lines I am explaining how the code works. Building a house from the Arduino based floor cleaning robot. In order to decide the ideas of my robot, I searched for vacuum cleaner robots online and got some ideas and images of the round shaped robots. So I decided to build a round shaped robot. To build the case of the body of the robot, I have plenty of options like foam sheet, MDF, cardboard, etc. But I choose the MDF because it's hard and has some water resistant properties. If you are doing this, we can decide the material which you choose for the bot. To build the robot, I took the MDF sheet, then drew two circles with radius of 8 centimeter, and inside the circle I drawn another circle of radius 4 centimeter. In the main loop, we have three sections for three sensors. As the sections work the same, but each of the different sensors in this section, we read the obstacle distance from each sensor and store it in each defined integer. To read the distance first, we have to make sure that the trigger pins are clear. For that, we need to select trigger pin too low for 2 microseconds. Now for generating the ultrasonic wave, we need to turn the trigger pin for 10 microseconds. This will send the ultrasonic sound and will help the pulsing function. We can read the travel time and store the value in variable direction. This function has two parameters. The first one is the name of the echo pin. For the second one, we have either high or low. High means the pulsing function will wait for the pin, and high the bounded sound wave it will start counting, then it will wait for the pin to stop the counting. This function gives the length of the pulse in microseconds. For calculating the distance, we will multiply the duration by 0.034 seconds. Safety of the most obvious advantage of utilizing robotics: speed, consistency, job creation, productivity, perfection, happier employees, safety, speed. And thank you.